These are the Chapter 8 Notes 1 on binomial distributions. Today we're going to talk about what a binomial distribution is and how it relates to probability. You just got done taking a 6-question multiple choice pop quiz. I'm guessing you didn't do too well by guessing, and it's a little frustrating. You would think, okay, on a 6-question test or quiz, chances should be pretty good. I get, better than what I got right. So we're going to find out today why your scores may have been as low as they were. First of all, a binomial distribution, you'll notice the prefix here, bi, refers to the number 2. So we're going to be referring to something that has 2 values to it. So in this case, a binomial distribution satisfies 4 conditions. The first one is that we're looking at a situation where there are 2 outcomes, and we view these outcomes as being either success or failure. Secondly, independent observations. We're assuming we're looking at a situation where what happens on one trial has no impact on what happens on the next trial. So independent observations. The third condition that's satisfied for binomial distribution is that the probability of success is the same for each observation. This means that the probability does not change from trial to trial. And the fourth condition that's satisfied is that in a binomial distribution there are a fixed number of observations. We will know at the beginning of the problem how many times we're repeating some particular experiment. When we calculate a binomial probability, the formula we use is this complicated formula that you see here. I want to interpret some of the variables that you'll see in this equation, starting with n. N in this problem is the number of observations. We had said that this number was fixed at the beginning of the problem, so we always know at the beginning of the problem how many times we're running this experiment. The number of observations is n in this formula. P stands for the probability, or the probability of success. We're going to utilize some sort of value here that is going to be a decimal between 0 and 1. K refers to the number of successes we want. For example, if there's a question that says you're flipping a coin 4 times, what's the probability of getting 3 successes? K would be 3. This parentheses around the n and the k is another way of talking about something that's called a combination, which you may remember from Algebra 2. It's sometimes abbreviated like this. On the graphing calculators, it's abbreviated NCR. And you will find this value located under the Math menu option on your calculator, and you'll see something that kind of looks like this right here. If you hit the Math button, go to Probability, you'll see NCR as the third command there. That's what we're going to be utilizing here. This is the number of ways of getting k successes in n observations. And while you don't need to know that, there is a formula for calculating this value. It's equal to n factorial divided by, in parentheses, n minus k factorial times k factorial. We will not be utilizing this so much as just plugging it into your calculator. If p is the probability of success, 1 minus p would be the probability of failure. And n minus k is equal to the number of failures. You will find these two differences located in your formula as well. On problem 2, you were asked on the 6-question 4-choice multiple choice pop quiz that you took earlier, what was the probability of getting exactly 4 questions right? Assume independence between questions and that each answer is truly a guess. Round to 3 decimal places. What we are looking for is the probability of getting exactly 4 questions right. We are looking for the probability that x is equal to 4. And if we take it back to our formula, k is the number of successes. We're going to answer this question using the formula up here. N is the number of observations, which would be 6 questions. K is the number of successes we're interested in. I want to know the probability of getting 4 questions right. P is the probability of success. If we're guessing on a 4-choice multiple choice test, that would be 1 out of 4, or 0.25. K is the number of successes, which again is 4. 1 minus p is the probability of failure. 1 minus 0.25 is 0.75. N minus k is what we get when we subtract the numbers in the parentheses there. 6 minus 4 is equal to 2. And if you want to write 6 minus 4, you can, or if you just want to write 2, you can do that as well. So I'll just put a little arrow. This is where we did 6 minus 4. And this is a value that you can calculate on your calculator. Again, to find 6 with this parentheses 4 with it, what you can do on your calculator is use the NCR command, which we talked about was under the Math menu option. And it'll look kind of like, let's see if I can pull it over here. It'll kind of look like this command right there, so you use that NCR command. And it'll kind of look like, so you'll write 6 NCR, or sometimes just C4 times the 0.25 to the 4th power and the 0.75 to the 2nd power. If you actually crunch this out in your calculator, you should get something small, 0.033. This is a probability of getting 4 questions right. So if you got 4 questions right on this test, good for you. There's only a 3% chance of getting that score. What's the probability of getting all 6 questions right if we use the same assumptions? If we kind of use the same formula as before, k is equal to 6, n, 6 observations, k, 6 successes. The probability of success, p, is still 25%. Your variable here is k, which is 6. We want 6 successes. 1 minus p is still 75%, the probability of failure. This number here is what you get when you subtract 6 minus 6. In this case, it's 0. And this is how you can find the probability of getting all 6 questions right. If you crunch this out, your calculator is going to say 2.44e negative 4. Remember, we don't write it like that. We write it like this. If you want to add decimals, you can write it as 0.000244. Now, there is a calculator shortcut because this takes a little while to write out, and we'll talk about this on the next page. There is a command that's called Binompdf, and you'll find it under the Distributions menu or second vars on your graphing calculator. If you hit second vars, vars is located kind of over by that down arrow key. Binompdf is this command here. I've kind of highlighted this value. Make sure you don't choose the one that says Binomcdf. We'll be using that one in a few days. On older calculators, you're going to be asked to type in 3 things if you're going to use this shortcut command. You're going to be asked to type in N, P, and K. Kind of think of it as spelling like the word napkin or nitpick. You're kind of using some of those same letters here. So if you type in the number of trials, 6, probability of success, 0.25, and K, number of successes, you'll get that same 0.033 number that we did back when we did problem number 2 on the front side of the worksheet. On newer calculators, it will tell you immediately, type in the number of trials. This is sort of like your N value. P is the probability of success. You can type in 1/4 or 0.25. And then the X value is actually K. I don't know why they call it the X value, but you're going to type in K right here. It'll generate the same solution when you're done, and that's a shortcut rule to using this formula. Similar to what we found on the last test, you do have to show this formula on a test if it's a free response question. But if you'd rather not type all this into your calculator and use the shortcut rule, who's going to know the difference, right? All right, so let's take a look at number 4. Write down the calculator command that would answer question 3, the probability of getting all 6 questions right. When you write this out here, when you type this in your calculator, it is going to start with Binompdf. You're going to type in the number of trials, which is 6. Probability of success, which is 0.25. And this time we want to know the probability of getting all 6 questions right. That's the last number we type in. If you're using the newer calculator, you're just going to use 6 for the number of trials, 0.25 or 1/4 for P, and 6 for the X value. And if you hit enter on your calculator, you should get the same number that you did right here. And when you get a chance, you should actually try that out. What's nice about the shortcut is it allows you to find a number of probabilities quickly, especially if you want to know the probability of getting any number of these questions correct. Now, we just talked about the probability of getting 6 questions right, and that was like 0.000244. To 3 decimal places, the probability of getting 6 questions right is basically almost impossible to 3 decimal places. Now, what's kind of cool is that you can use the Binompdf command very quickly to generate these other probabilities. All we're going to do is replace this number, or if you're using the newer calculator, this number here, with the numbers 0 through 5. And if you do that, you should be able to generate these probabilities that you see on the rest of the chart. Armed with that information, you should be able to answer question 5, which is generate the numbers in the table. Problem 6, which is make a histogram. We already know the height for the histogram at 6 questions right is 0. So we're not really going to have any graph here. And for 4, you can only go up to 0.33, so that's going to be a pretty small graph here too. All right, finally, the last step. Once you complete your histogram for 5 and 6, describe the distribution of correct answers from a 6-question, 4-choice, multiple-choice test. To describe a binomial distribution, we're going to use this quick notation that says capital B, which stands for this is a binomial distribution. Instead of talking about SOCs, shape, outlier, center, and spread, all you have to say is B, it's binomial, N is the number of terms, which would be 6 questions, and P is the probability of success, which is 0.25. So what's kind of weird in a binomial distribution is you don't have to talk about shape, outlier, center, and spread. B kind of gets at the idea of what the shape is. It's a binomial shape, which we'll talk about in a few days. N is the number of trials, which doesn't really deal with center and spread, and 0.25 is your probability of success. This describes the distribution, and again, we'll talk in a few days about why we no longer have to talk about SOCs for this type of distribution. But that's it for today, and you're moving on to your homework assignment from here.